Hello, good afternoon students. Once again welcome back to online classes. So in today's class I am going to discuss on Colpitt's oscillator. So in previous class we have studied the one type of LC oscillator. So that LC oscillator is our Hartley oscillator. So in that Hartley oscillator the feedback network, it consists of a inductive feedback. So, but whereas here one more circuit is given to generate the high frequency signals. So, that is nothing but to generate the high frequency electrical oscillations, they can be generated by means of Colpitt's oscillator here. So, this circuit, it actually consists of same as that of your Hartley oscillator. The only difference between your Hartley oscillator and Colpitt's oscillator is a feedback network, that is nothing but our tank circuit. In our previous Hartley oscillator, the tank circuit, it consists of a inductive feedback, but whereas here we are taking the feedback voltage across C2, because of that here it is called as a capacitive feedback tank circuit or a feedback network. So, that is going to be employed in our Colpitt's oscillator. So, here in this circuit we have to first draw the circuit diagram. So, after drawing the circuit diagram, explain about the circuit, that is circuit explanation you must write. So, what is that circuit explanation here? So, this circuit, it consists of amplifier along with the feedback network in order to generate the electrical oscillations of desired frequency. So, in that R1 and R2 and RE resistors, so they are used to provide the necessary bias for the transistor. So, this transistor has to be operated in its active region. So, in order to make it to operate in an active region, the proper values of DC biasing, that is R1, R2 as well as RE, they are properly selected so that it provides proper DC biasing to your circuit. Not only that, here in this circuit there is a emitter bypass capacitor is there. So, this capacitor, it allows your emitter current, unwanted electrical AC emitter current, that is going to be bypassed to the ground. So, by means of this emitter capacitor. So, at the input side as well as at the output side, there are the coupling capacitors are there. So, these coupling capacitors, they allow only AC signals and blocks the DC signal. The main function of these coupling capacitors, so CC, they are one is connected at input side, another one is connected at output side. Their function is to allow AC signal and to block the DC, so that a pure AC sinusoidal signal or electrical oscillation, they can be generated at the output of your oscillator circuit. That is our main concept. So, along with that, in this circuit there is choke is there. So, this choke is nothing but inductor coil of radio frequency. So, that is called as radio frequency choke. This one we call it as a radio frequency choke. So, its function is to block the AC component and to allow DC to flow through it. So, that is, it acts like a short for DC supply and acts like a open for AC. So, that whenever it is present in this circuit here, it provides the isolation between your DC supply voltage and electrical oscillations which are generated at the collector terminals. So, here whatever electrical oscillations these are going to be generated here, to isolate from that your DC supply, for that isolation to separate the two types of signals here, one is of DC and another one is of AC, to provide a isolation, this RFC choke is going to be employed. It acts like a short for DC and acts like a open for AC. So, this is a function here. Not only that, in this circuit there is a tank circuit is also connected. This tank circuit we already call it as a oscillator circuit. So, in this oscillator circuit there are the two capacitors are there, C1 and C2. So, the potential across these capacitors are 180 degree out of phase with each other. Illen potential generate agirtada. That potential signal and this signal both are how much they are phase shifted. So, they are phase shifted by an angle of 180 degree. So, like that proper values of C1 and C2 are selected. So, this C1 C2 combination is connected in parallel with your inductor coil. So, that is connected in a tank circuit. So, this is regarding about your circuit explanation. Now, and be careful while drawing the circuit that this amplifier, this emitter terminal should be always connected to ground. Idana draw ಮಾಡೋದು ಮರಿಬೇಡ್ರಿ. So, ground must be always, it is very important, don't forget to draw this ground diagram. So that means that it passes unwanted AC signals to the ground. So that is the main concept of that ground is there. So now regarding about working we have to explain. ಇವಾಗ ಏನಾಯ್ತು ರೀ ಸರ್ಕ್ಯೂಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಆಯಿತು. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಮೂವಿಂಗ್ ಆನ್ ಟು ದ working of this oscillator circuit, how it generates the electrical oscillations. So that working can be explained with an example here. So that is nothing but it is similar to that of your previous Hartley oscillator working, but here in this whenever power is switched on, so that is nothing but whenever power supply is given here, immediately what happens, the collector current starts flowing inside the circuit. So that collector current, it increases in the transistor amplifier. So when that collector current increases, it charges your capacitors C1 and C2. So here there are two capacitors are there, they are going to be charged to their peak value. Whenever current flows, they are get charged to their peak values. Because of that, once these capacitors are going to be charged, then after they find the path for discharging, so because of that these charged capacitors, they discharge through the inductor L. So because of that what happens, the charging and discharging, so it continues inside the tank circuit. Because of that electrical oscillations are going to be produced. Once these electrical oscillations are going to be produced, the output across or potential voltage across your capacitor C1, it is nothing but the required electrical output, electrical oscillations of sustained amplitude, so or constant amplitude, they are going to be obtained here, the potential, and whatever the potential across your capacitor C2, that is going to be applied back to the input as an feedback voltage. So that is the voltage drop or potential across capacitor C2 is applied as an feedback signal to your input of amplifier circuit. So that what happens, so this voltage drop across C2 is such that it produces a phase shift of 180 degree. So that is in a feedback signal a phase shift. So that is the phase shift of 180 degree phase shift, that is going to be introduced by your potential across C2, as well as one more 180 degree phase shift that is going to be produced by this voltage divider biasing circuit, that is an amplifier which also produces 180 degree phase shift. So therefore the total phase shift inside the closed loop in a circuit is how much, 180 degree plus 180 degree. So because of that 180 plus 180, it gives rise to 360 degree phase shift. So as a result of that it produces the positive feedback. That is nothing but because of this 360 degree phase shift in a circuit, our Barkenshine criteria is satisfied. So that is the circuits whenever they are going to operate as an oscillator, Barkenshine criteria must be satisfied. That is first criteria, it tells that the total phase shift around the closed loop should be 360 degree. Now it is going to be achieved in this circuit. Because of that, that is the necessary conditions for amplifier or your oscillator circuit to generate the sustained oscillations. So they are going to be operated here. So one more condition is to be satisfied now. So that electrical oscillations, they are taken at the output of your capacitor C1. So this one is output here, we get the electrical oscillations, and these electrical oscillations, they have the frequency. So the electrical oscillations of frequencies are given by f naught is equal to 1 by 2 pi root of LCEQ, where actually it is LC, but here there are two capacitors are going to be employed in a tank circuit which are connected in series. So for that we write it as, we have to find the effective capacitance C equivalent. So therefore that C equivalent is equal to C1 C2 divided by C1 plus C2. By using this formula we calculate the effective capacitance. So by proper selection of this capacitor as well as proper selection of your inductor, it gives rise to your desired frequency of electrical oscillations. They are going to be generated at the output of this oscillator circuit. So, here at the collector terminal between the ground, electrical oscillations they are going to be produced. So, they are going to be finally delivered to your required loads wherever for a particular application they require. So, in such application these signals are going to be used there. So, this is the frequency of oscillations. Now, we have to find the beta factor as well as open loop gain of this Colpitt's oscillator. So, that is nothing but in a feedback network or in feedback circuit, in feedback network, the voltage feedback ratio is given by feedback ratio or fraction is given by voltage feedback ratio is given by beta. Since we know that beta is the voltage feedback ratio, so that is given as the ratio of your feedback voltage to the output voltage. So, what is this feedback voltage? So, this feedback voltage is nothing but the voltage drop across your capacitor. So, this one is we are taking it as a feedback voltage that is going to be applied back to the input side. So, this feedback voltage is obtained across your capacitor C2. So, therefore, we write it as V can be written as I into impedance. So, here capacitors means we do not consider the resistor, instead of that we consider the impedance here. So, what is the difference between impedance and resistance? Impedance is nothing but the opposition offered by the flow of AC current, flow of AC electrical current, then it is called as a impedance. So, that is that impedance is going to be offered by both C1 and C2 here. So, that impedance we write it as a XL. For capacitor, how we write? I into XL. XC, so that is capacitive reactance. Capacitive reactance, it is written as XC. So, here substitute that values Vf, we know that Vf is the product of your I into XC2 here, because the capacitor is C2, I into XC2, and the product of V0 is nothing but the voltage drop across your capacitor here. So, this one is nothing but V0. So, that is written as I into XC1. So, here I get cancels. What are these XC1 and XC2? They are the capacitive reactances. XC2 and XC1 are the capacitive reactances. So, these capacitive reactances they can be written as XC for capacitor is written as 1 by omega C. So, therefore, here it is written as 1 by omega C2 whole divided by 1 by omega C1. So, where omega is the angular frequency, it cancels here. So, because of that we get here C1 divided by C2. So, the feedback fraction for Colpitt's oscillator is given as beta is equal to C1 by C2. So, by proper selection of these capacitor values, so we can make the second condition of Barkenshine criteria is to be satisfied. For that purpose we know that second criteria, so that is product of your open loop gain and feedback factor should be equal to 1. So, applying this condition here, and in order to calculate the proper value of A open loop gain, so A is equal to 1 divided by beta. So, here from this equation A is equal to, we bring this beta into the numerator, cross multiply. So, because of that we calculate A as 1 divided by beta. Since we have already calculated the feedback fraction of substitute here, that is nothing but 1 divided by C1 divided by C2 is C2 divided by C1. So, that is A open loop gain for an amplifier should be equal to C2 by C1. If these proper values of capacitances they are going to be employed in the circuit, then Barkenshine criteria is satisfied. Once your Barkenshine criteria is satisfied, the sustained constant amplitude oscillation, electrical oscillation, they can be obtained at the output of your oscillator circuit. So, these are the conditions. So, in examinations they may ask about explain the working of Colpitt's oscillator, or some problems are also given. Before going to solve those problems, so and let us come to know about what are the advantages and disadvantages of these LC oscillators. So, we are comparing these oscillators with the other type of oscillators like your RC oscillators as well as crystal oscillators. Compared to that, which one is better? So the comparison is made here. So that is the advantages of LC oscillators and disadvantages as well as applications of LC oscillators. What are the advantages of LC oscillators, and if they have advantages, disadvantages are also there. Disadvantages of LC oscillators, and finally application areas where these LC oscillators are going to be employed. Applications of LC oscillators. So what are the advantages of LC oscillators? The advantages are here. The LC oscillators, they are used to generate the high frequency signals or high frequency electrical oscillations. So that means that here LC oscillators, they are used to generate high frequency electrical oscillations, high frequency electrical oscillations. Electrical oscillations or signals, electrical signals generate ಮಾಡಲಿಕ್ಕೆ use ಮಾಡ್ತಾರೆ. Not only that, it is very easy to vary. That is nothing but the frequency can be easily varied. So here the frequency of oscillation can be easily varied. Oscillation can be easily varied. So these are the two advantages. So whenever you require to change the frequency, then by proper selection of your inductor and capacitance values, you can change the frequency of oscillation. So that frequency can also be easily varied. So these are the advantages of that LC oscillator circuits. Both of LC oscillator circuit, they may be either your Hartley oscillator or it may be your Colpitts oscillator. So for both them it holds good. Next one is the disadvantages. Along with the advantages, so these circuits, LC oscillator circuits also have the disadvantages. What are those disadvantages here? So at low frequency, what happens? Whenever at low frequency applications, low frequency means frequency is very much less. Whenever frequency required is less, then there is a values of your capacitor and inductor, they becomes larger. So because why? F is it is inversely proportional to your square root of values of your capacitor and inductor. So if frequency is less, the required frequency is less means the reciprocal, these are F is the inversely proportional to square root of your LC value. Because of that, at low frequency what happens? The values of capacitance and inductance coil, they are very large. So the larger values of capacitance and inductance, when they are going to be employed in the circuit, then the size of that circuit becomes very bulky. Size ಏನಾಗ್ತದೆ ದೊಡ್ಡದಾಗಿಬಿಡ್ತದೆ ರೀ. So because of that, it is not going to be employed for minute applications. Wherever a delicate or minute applications are there, in such conditions, so such circuits are not portable as well as they are not going to be handled properly. So because of that disadvantages, so that means that at low frequencies LC oscillators, they are not going to be employed. So they are not suited for low frequency. These LC oscillators are not suited for low frequency application, not suited for low frequency applications. Why? Because at low frequency what happens? Larger values of capacitors and inductors are required. So whenever larger values are there, their size of that components, inductor and capacitance also very large. So therefore the circuit of oscillator itself becomes very large. So which is not suitable for particular applications. So, because of that this one has the disadvantage. So, next disadvantage is that construction of circuit is very expensive. Construction of such oscillator circuit, LC oscillators, is expensive. Cost irtadri, bhala cost agtadri. So, whenever they are going to be employed low applications, then their size increases. As their size increases, the cost of that components itself, passive components itself is also increased. Because of that the circuit itself is very much expensive. So, this is the disadvantage. So, next is coming to the application areas of these LC oscillators. So, I already told you that these LC oscillators, they are going to be employed to generate the high frequency signals, radio frequency signals. So, because of that they are going to be used in your TV and radio transmitters. TV transmitters and radio transmitters, they make use of these LC oscillators, transmitters. Not only that, in TV and radio receivers also they make use of these LC oscillators. So, these are the applications areas of your LC oscillators. So, this completes the theory of LC oscillators. Now, let us solve the problem related with your Colpitt's oscillator. This type of problems may be going to ask in your examination for 5 marks. So, let us solve such problems here. Problems of Colpitt's oscillator. Problems on Colpitt's oscillator. Problems on Colpitt's oscillator. Here the frequency of Colpitt's oscillator, the frequency of Colpitt's oscillator, the frequency of Colpitt's oscillator is 18 megahertz, and inductor, determine the inductor value, determine the inductor value, so that the capacitor values are C1 is given as 100 picofarad and C2 is given as 10 picofarad. So, E type problem ask ಕೇಳ್ತಾರೆ ನಿಮಗೆ examination and 5 marks ಗೆ. So, here whatever the data is given, first write down that. So, that data is nothing but your solution. So, given data, in given solution we have to write given data, what is there. So, they have given the frequency of oscillation. So, that is frequency of oscillation is how much? 18 megahertz. Mega means how much? 10 raised to 6 hertz frequency is given, as well as capacitance is given C1 100 pico. Pico means what? 10 raised to minus 12 farad, as well as C2 is given, that is 10 picofarad, 10 raised to minus 12 farad, and they are asked to find out you the inductance of that coil. So, here we know that frequency of oscillation is given by f is equal to 1 divided by 2 pi root of LCEQ here for Colpitt's oscillator. So, we have to determine first CEQ find out mod on tree. CEQ is equal to C1 C2 divided by C1 plus C2. So, therefore, C1 C2 is nothing but C1 is here 100 pico into 100 pico, 10 pico divided by 100 plus 10 pico, 100 pico plus 10 pico. So, therefore, we get here 100 into 10 is 1000, 1000 into 10 raised to minus 12 and 10 raised to minus 12. You have to separate it in three. Still, I will not multiply both these two terms. Why? Because it cancels in a next step. So, 100 plus 10 is how much? That is 110 picofarad. So, that is 110 picofarad here. 1 pico cancels. So, 1010 cancels. 100 divided by 11 pico. 100 divided by 11 into 10 raised to minus 12. So, that is how much? 100 divided by 11. 9.09 picofarad. 9.09 into 10 raised to minus 12 farad is a C equivalent, the value of equivalent capacitance. Now we have to determine the L. So before determining L, first arrange this equation properly so that L should come in a left hand side. So in order to make that arrangement, first squaring the equation 1 on both sides, squaring equation 1, squaring the equation 1 on both sides, square ಮಾಡಬೇಕ್ರಿ, because we have to remove the square root ಅನ್ನು remove ಮಾಡಬೇಕು. For that purpose we have to square here. So that is f square is equal to 1 divided by 2 pi whole square into root of LC square means root cancels here, just here remains is your L into CEQ. Now rearrange the term. So rearranging that term, so that L we have to calculate the L. Nam concept enadari, we have to find the inductance value. So bring L here in numerator or cross multiply your L, and so that here the equation reduces to 2 pi square means what here, 2 pi square means 4 pi square, 2 into 2 is 4 pi square into f square. So f should be cross multiplied to bring it to the numerator on your right hand side, and f square into CEQ. Now substitute the values. We know all the values of this. Substitute here. L is equal to 1 divided by 4 into pi square means what, 3.142 whole square into f square is how much, f is given as 18 megahertz whole square. So that is f square means 18 megahertz whole square into CEQ. So now only we have calculated 9.09 into 10 raised to minus 12. So therefore L is equal to 1 divided by 4 into 3.142 square, 3.142 into 3.142 is equal to how much, 9.87. So this is the value of 9.87. 18 into 18, 324 into 10 raised to 6 whole square is 10 raised to plus 12 into 9.09 into 10 raised to minus 12. This 10 raised to plus 12 minus 12 cancels here. So because of that we get L is equal to 1 divided by 4 into 9.87 into 324 into 9.09. So these are the remaining terms. So now multiply all these terms here, that is 4 into 9.87 into 324 into 9.09. So we get 4 into 9.87 into 324 into 9.09. That is hardly we get about 1 divided by 116,279.24.9168. So the reciprocal of that, divide this value, then we will get nearly about 8.6. That is 8.6 micro 10 raised to minus 6 value. So Henry, or we may write it as L is equal to 8.6 micro Henry. So this is the required answer or inductance value for the given value of capacitance and frequency. For that we have calculated how much value of inductance should be connected. So in the circuit there is a 8.69 micro Henry inductance must be connected in a circuit in order to generate the frequency of 18 megahertz. So let us solve one more problem. So it is also very important as per your point of examination. Consider second one here. Calculate frequency and feedback factor. Calculate frequency and feedback factor for the circuit given below. Here. For this circuit, we have to find the frequency and feedback factor. So the circuit is here. It consists of a tank circuit. Only simply tank circuit is given here. Instead of giving all values, they have given only the tank circuit value, which is a very important part to determine the frequency of oscillations. So here to amplifier circuit. Here also to the amplifier circuit. Inductance, capacitor C1, C2. So this inductance is how much? 100 microhenry, and capacitor is given as 0.01 microfarad, as well as here also capacitance value is given as 0.22 microfarad. So determine for this particular problem, we have to determine is circuit ne gain and provide madara, then first baridi given data. So given data is inductance is given. Inductance value is how much? 100 microhenry. Micro means 10 raised to minus 6 Henry. So inductance is given. Capacitance is given as 0.1 microfarad. So this is 0.1 microfarad. C1, C2 is given as 0.22 microfarad, and they have asked to find out the frequency of oscillation f is how much, as well as beta factor, feedback fraction is how much. For this particular circuit, frequency we know the formula 1 divided by 2 pi root of L into CEQ, and beta is calculated using your C1 divided by C2 formula. So from these formulas we have to calculate directly. They have given ella values kotara, find out madbekri. So here in this circuit CEQ is equal to C1 C2 divided by C1 plus C2. So now substitute the value of C1 substitute madri. So that is 0.1 into 10 raised to minus 6 into 0.22 into 10 raised to minus 6 divided by 0.1 into 10 raised to minus 6 plus 0.22 into 10 raised to minus 6. So therefore we get here 0.1 into 0.22 is 0.022 divided into 10 raised to minus 6 and 10 raised to minus 6. Keep as it is. Hinge idri, then multiply ಮಾಡಬೇಡ್ರಿ. So 10 raised to minus 6, 10 raised to minus 6. Keep them as a separate part so that it will cancel in the next step. So 0.1 plus 0.22. 0.1 plus 0.22 is 0.32 into 10 raised to minus 6. So therefore 1 10 raised to minus 6, 1 10 raised to minus 6 cancels here. Remaining is your 0.022 divided by 0.022 divided by 0.32 into 10 raised to minus 6. So that is 0.022 divided by 0.32 is 0.068. So that is 0.06875 into 10 raised to minus 6 farad. So this is the equivalent capacitance. Now we have to substitute in the equation. So that is F naught, or frequency of oscillation is given by 1 divided by 2 pi root of LCEQ. So F is equal to 1 divided by 2 pi into root of L. L is how much? 100 microhenry. 100 into 10 raised to minus 6 into, now only we have calculated 0.068 into 10 raised to minus 6. So now the multiplication of this into 100 is how much? 6.875. Therefore frequency of oscillation is given by 1 divided by 2 pi into root of, here multiplying with 100 into 6 0.68 is 6.875. 6.875 into 10 raised to minus 6, 10 raised to minus 6, we get 10 raised to minus 12. So that is, therefore f is equal to 1 divided by 2 pi into root 68. I can split these two terms here. So these two terms are splitted like this. Root of AB is equal to, we can write it as root A into root B. So like that I am separating here. So that is entire root. Now it can be splitted into two roots. So that is 6.875 into root of 10 raised to minus 12. So that the problems become simpler here in order to solve here. 2 into 3.142 into root of 6.87. Its root value is 2.622, as well as 10 raised to minus 12 root. 10 raised to minus 12 root means 10 raised to minus 12 raised to 1 by 2. So therefore here 2 ones are 2 6 are, that means that we get here 10 raised to minus 6. So it is written as 10 raised to minus 6. Now directly multiply all the values now. That is 2 into 3.142 into 2.622 into 622. So that is 16.46, 16.476. So bring this 10 raised to minus 6 into numerator, that is 10 raised to plus 6. So this can be written as 10 raised to 3 into 10 raised to 3 divided by 16.476, which is equal to 10 raised to 3, I can write it as 1000. 1000 divided by 6.476 into 10 raised to 3. So that is 1000 divided by 16.476, that is 60.69 kilo, 60.69 kilohertz. So this is the required frequency. F we get is 60.69 kilohertz. So one we have calculated. So next is we have to find the beta factor. Beta is equal to C1 divided by C2. C1 is how much? 0.1 into 10 raised to minus 6. C2 is 0.22 into 10 raised to minus 6. 10 raised to minus 6 cancel here. 0.1 divided by 0.22 is 0.4545. It is unitless. Don't write any unit for this. So it is unitless. Beta is 0.4545. In this way we have to calculate. ಇಷ್ಟೆಲ್ಲ ಡೀಟೇಲ್ ಆಗಿ ಯಾಕೆ ತೋರಿಸ್ತೀನಿ ಅಂತಂದರೆ ಎಕ್ಸಾಮ್ನಾಗ ಏನು ಮಾಡ್ತೀರಿ, ಫಾರ್ಮುಲಾ ಸಿಂಪಲ್ ಅವ ರೀ. ಸೊ ಫಾರ್ ಆಲ್ ಯುವರ್ ಆಸಿಲೇಟರ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಫಾರ್ಮುಲಾಸ್ ಆರ್ simple, but whenever in examination they are going to ask, you make a mistake, small mistakes. Because of that I solve these problems in detail so that it becomes easier you to solve in examination without using your scientific calculators. So for that purpose I have solved problem like this step by step. So in main examination also you try the problem solution in this way only. Hinge solve madri examination naga. So next moving on to our other type of oscillators, sinusoidal oscillators. There are three types. So one is LC oscillator is over. So now the next oscillators are your RC oscillators. So that is RC oscillators. So these are second type of oscillator circuits. Here also we studied two types of RC networks, RC phase shift network as well as Wien bridge oscillator. Here we study. So before going to study that, what are these RC oscillators? RC oscillators are nothing but these are the oscillator circuits which in a feedback they are going to make use of RC network. So because of that these oscillators we call it as a RC oscillator circuits, and they produces the low frequency electrical oscillation signals ಇವೇನು ಮಾಡ್ತಾವೆ ಲೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಜನ್ರೇಟ್ ಮಾಡ್ತಾವೆ. ಬಟ್ ವೇರಾಸ್ ಇನ್ ಎಲ್ ಸಿ ಆಸಿಲೇಟರ್ ದೇ ಜನರೇಟ್ ದ ಹೈ ಫ್ರೀಕ್ವೆನ್ಸಿ ಸಿಗ್ನಲ್ಸ್. ಸೊ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಆರ್ ಸಿ ಆಸಿಲೇಟರ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಆರ್ ಆ್ಯಂಡ್ ಸಿ ನೆಟ್ವರ್ಕ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಎಂಪ್ಲಾಯ್ಡ್. ಸೊ ವೈ ದಟ್ ಆರ್ ಆ್ಯಂಡ್ ಸಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಎಂಪ್ಲಾಯ್ಡ್ ಇನ್ ದ ಸರ್ಕ್ಯೂಟ್? ವಾಟ್ ಈಸ್ ದ ರೀಸನ್ ಫಾರ್ ಯೂಸಿಂಗ್ ದಟ್ ಆರ್ ಸಿ ನೆಟ್ವರ್ಕ್? ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಆರ್ ಸಿ ನೆಟ್ವರ್ಕ್? ದ ಮೇನ್ ರೀಸನ್ ಈಸ್ ಟು ಪ್ರೊವೈಡ್ ದ phase shift in a signal. So that phase shift, in order to achieve the phase shift of 180 degree, so we require RC networks. So first let us study the basic concept of that RC network, that is the principle of phase shift. Principle of phase shift in RC network or RC circuit. Principle of phase shift in RC circuit. So let us consider the RC circuit here. RC circuit means which consists of a capacitor and resistor combinations. So here this one is RC network. So we are taking the output voltage across this resistance. Voltage el togotiri output voltage. The output voltage is measured across your resistance, whereas input is applied at the input side of this RC network. Here input signal is applied like this. That signal is going to be phase shifted. Phase shift agtadri. That is going to be phase shifted. E type is the signal, E type phase shift agtada. So why? Because here to achieve the phase shift, so in RC network what happens always, whenever suppose assume that if a AC input voltage is applied here, so the output voltage always leads your input voltage by an angle of phi. ಸೊ ಯಾವಾಗಲೂ ಏನಾಗ್ತದೆ, ಕೆಪಾಸಿಟರ್ ಯಾವಾಗ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ ಆವಾಗ ಏನಾಗ್ತದೆ ಅಂದರೆ ಇನ್ ಅ ನೆಟ್ವರ್ಕ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಲೀಡ್ಸ್ ದ ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್. ಲೀಡ್ಸ್ ಅಂದರೆ ಫೇಸ್ ಆ್ಯಂಗಲ್ನಾಗ ಮುಂದೆ ಹೋಗ್ತದ್ರಿ. ಸೊ ವಾಟ್ ಎವರ್ ಯುವರ್ output voltage is there, that leads your input voltage by an angle of phi. So this is the phasor diagram of, already we have studied this phasor diagram in our first year. So in our electrical passive components of study of your capacitances, in that we have studied this effect of phasor diagrams. So this one is Vi and V0. V0 is leading by VI by an angle of phi. Leading ಅಂದರೆ VI ಕಿಂತ V0 ಎಷ್ಟು ಮುಂದಿರ್ತದೆ ಅಂದರೆ phi angle ಇಂದ ಮುಂದಿರ್ತದೆ. Why? Because of this capacitance. So here whenever an AC input voltage is applied, then whatever the output voltage that is going to be obtained at the output of resistance, this output voltage it leads ಮುಂದ್ಗಡೆ ಹೋಗ್ತದ್ರಿ, it leads the input voltage by an angle of phi. So that phi angle we can write it as tan phi is equal to omega, that is tan phi is equal to omega c divided by, sorry, so this tan phi is equal to xc by r. So this tan phi is calculated by means of a formula. So that is xc by r, where xc is nothing but, so this xc is nothing but the capacitive reactance divided by resistance of the network. By using these values we can calculate the tan phi. So where xc is equal to 1 divided by 2 pi fc. So xc is calculated as, already we know that capacitive reactance. So this capacitive reactance is given by, calculated by the formula of 1 divided by omega c, where omega is angular frequency of signal, AC input signal, angular frequency. So that is equal to, omega is equal to 2 pi f. Angular frequency is equal to 2 pi f. Now here 1 by 2 pi fc. So this phi angle, that is nothing but phase shift angle. So with what angle it is going to be varied? So this phase angle, it depends upon mainly on the capacitance value as well as here resistance value. Xc is 1 by omega c. So because of that here 1 divided by 2 pi fc r. So where here it depends upon the values of your capacitor and resistor, what values you are selecting, accordingly that the phase angle varies. So phase angle varies means, if assume that your resistance is infinity, Suppose assume that resistance value is infinite. So, when resistance value is infinite, this entire term is 1 divided by infinite, means almost it is equal to 0. So, tan phi of 0 is nothing but their phi value, it is equal to how much? It is 0 degree. So, whenever an infinite resistance is connected, then your output voltage is in phase with the input voltage, that is phi is equal to 0. Suppose assume that if resistance value is 0, ಈ resistance 0 connect ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಇತ್ತಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ರಿ. If it is a short circuit, then we get here how much? If we substitute 1 divided by 2 pi fc into 0, so that is 1 divided by 0 is almost equal to infinity. Tan phi is equal to infinity means phi angle, phi is equal to tan inverse of infinity, which is phi angle is how much? 90 degree. So, that is output varies or leads the input voltage by an angle of 90 degree. So, whenever by selecting the proper values of resistance here, we can obtain the proper values of phase shift in our circuit. So, that is going to be obtained as designed. This concept is needed because in order to generate the 180 degree phase shift in the feedback circuit, ಇದೆಲ್ಲ ನಾವು ಯಾಕೆ ಸ್ಟಡಿ ಮಾಡಲಿಕ್ಕತ್ತೀವಿ ಅಂದ್ರೆ this concept is useful in a RC phase shift network where 3 stage or there is a 3 section RC network is going to be employed. So, 3 section RC network here, 1 section RC network. So, next another section RC network and one more section RC network is connected here. So, that is capacitance, resistance and so that here output voltage is obtained here at the output of resistance. Here input signal is applied. So, this stage we call it as a 3 stage. Why 3 stage? One RC network, another RC network, another RC network. So, these 3 sections of RC networks are employed in this circuit. So, why? In order to generate the 180 degree phase shift. So, that first stage RC network, it produces a phase shift of 60 degree. Idu RC network ಏನು ಮಾಡ್ತದ್ರಿ? It produces a phase shift of 60 degree here. So, that signal is again applied. So, again one more RC network is there. So, this also produces a phase shift of 60 degree. Further, that output of signal is applied to this circuit, next network. So, that also produces a phase shift of 60 degree by proper selecting the values of R and C. So, that the total phase shift is how much? 60 plus 60 plus 60 is equal to total phase shift 60 plus 60 degree plus 60 degree is equal to 180 degree phase shift. So, therefore, this concept that is going to be employed in your RC phase shift network. For that we study this principle of phase shift in a RC network, how that phase shift is going to be applied or used in order to get the total phase shift of 180 degree in a feedback circuit. Instead of using tank circuit here, the feedback circuits, so they are going to be used so that they produces a phase shift of 180 degree. So, that RC phase shift oscillator as well as Vein bridge oscillator, we study that in a next class. So, here I conclude my class. Thank you.